All right, well, let's get started. Hello, everyone. This is Mick Emmett from Sematext. I want to welcome you to today's Docker logging webinar. We're obviously happy you took the time to be with us, and we plan to make it worth your while. We've got a lot of content in here, diagrams, how-to steps, and a lot of things that'll help you with Docker logging. So before we get started, a few things to note. After the webinar is over, we'll have a short Q&A session. So if you do have questions, please submit them during the webinar. We'll collect them, and at the end, we'll go through some of the questions that come in. You'll see a questions piece or a segment on your control panel. Any questions that we don't get to during the Q&A, we'll make sure that we address individually. So if you have a question, some way, somehow, we'll get you an answer. We'll also be sending out a follow-up email that has links to this presentation that you're going to see today, a recording of the webinar, and also some relevant Docker content. All right, so before I get started, I just want to give you a brief overview for those who are unfamiliar with Sematext. A lot of you probably know us as a search and big data consulting company. We focus on Solr and Elasticsearch, but we also provide support for other data platforms as well. But what's relevant for today, for this particular webinar, is that we build on-premises and cloud services for performance monitoring and log management. And both of them feature Docker monitoring and logging support. So SPM is the monitoring tool. It's actually monitoring, alerting, and anomaly detection for applications that many of you probably find critical, like Docker, CoreOS, Spark, Elasticsearch, Kafka, Cassandra, Node.js, and a whole bunch of others. It also covers core infrastructure metrics and has some advanced features like distributed transaction tracing. And Logsene is a little different. It's actually a centralized logging tool. And among other capabilities, it exposes the Elasticsearch API. It works with Kibana. It has built-in alerts and anomaly detection like SPM. And also, speaking of SPM, it integrates, so you can correlate metrics, events, and logs. And if you're a DevOps person and you currently use multiple tools or services for monitoring metrics, centralized logging, you'll probably be able to appreciate being able to see all of that in a single unified UI. And that's what Logsene and SPM together do. Anyway, you'll see some of Logsene today as my colleague goes through the Docker logging webinar. So lastly, a note about Docker monitoring. We did a couple webinars a few weeks back, and we just actually added a new one for next Tuesday, October 6th. So if you're interested in Docker monitoring, you can sign up for that. I'll include a link in the follow-up email that we send out after this. All right, well, let's get started. I'd like to introduce today's presenter, my colleague Stefan. Stefan is our DevOps evangelist. He's also our in-house Docker expert, and he's built most of the Docker monitoring and logging services that you're going to see today, and he has a lot of insights into Docker that should help you better manage your own Docker setup. So with that, I'm going to turn it over to Stefan, and he'll get right into the presentation.
Thank you, Mick. Welcome to all, and I'm in Germany, so it's evening already here, so I say also guten Abend to everybody. And I would like to start with the agenda. First of all, I would like to explain what is centralized log management, and then I go over to the Docker specifics, talking about challenges, and you will also see how to use log drivers, logging containers, and also a bit of our solutions. So what is centralized log management? I think we all know what are log files and logs. The challenge with centralized log management is to get all the information in a single place, so we have a centralized storage for all our log files, and this allows us to add advanced functionality, for example, indexing for full-text search. That's the typical use case. Normally nobody looks into the logs until something goes wrong, and then we want to find quickly the place where something happened. Another not so known technology is to do alerts on logs. Means if a specific log message appears or the frequency of specific log messages appear, that we can raise alerts on it and notify the administrator about the issues that happened. Or we define alert queries and alert you specifically for your alert queries. The other thing you can do with centralized logs is you can put analytics on it. For example, if you collect web server logs, you can then do your web analytics. Or if you like to find out how often a specific error happens, you can then easily get an overview in dashboards and charts how the behavior of the system is, or about general things, the log frequency or the number of services you are running when you use an Elastic service. So there are a lot of reasons to introduce centralized log management if you haven't done already. And there are a few steps to go to reach this goal. It starts already when we install an application that we get several options to configure our applications for logging. Either we have text-based logs, we might have influence to the log format, we have influence where the logs are stored. So with every application we have to think about logging and how to deal with it. Then we have to move over to a second area, which is the domain of log shippers. When I say log shipper, I mean a software that takes logs from one place, transforms the data to structured data, and forwards these logs to a central storage. In this domain, we find tools like Logstash, Fluentd, or our syslog, which has also outstanding capabilities and a great performance. So for the log shippers, we have to find out where are our logs to collect it. We need to know in which format. Typically, you define then patterns for the log parser to extract specific values out of the text log lines if you don't log in JSON already in your application. And using then log forwarding functionality to ship the logs to a remote site or a central server that stores and receives these logs. Typically, we find the next step to enable search is to do the indexing right. Here we have to deal, if you, for example, use Elasticsearch or our solution Logsene, with the mapping of fields into the full text index. There are many things to know about. And if we get this structured data, we can then do analytics. So if we extract, for example, numeric data out of the logs, then it's much easier to create a nice chart or dashboard out of it, or do very structured alerts based on this structured data. To get structured data, we have to look into different places. First of all, the application. If your application allows to write structured logs, for example, to log directly in the JSON format, you should use it. In this case, you save the next step in the log shippers to pass text content to structured data, and it makes it much easier to index this data in the full text search engine. And the result is then a good visualization. If you don't structure your data, you might have problems later on to visualize, or you might have problems in the search. And I know situations where people say, can you give me a chart of specific issues happened in the logs or of numeric data which is inside, and if there is no preparation to structure the data, it will not succeed. So please think about it right from the beginning, from the application to the log shippers, over the indexing to get good results at the end. So let's go what is to the topic of Docker logging. What is the special challenge there? First of all, there is a different way to access logs, so we don't get it from the files. In this case, we get the logs from the Docker daemon. There are different ways to forward logs to a central data store. And we have to ask ourselves where to place the log parsing and think of deployment of logging tools, either containers on a local host. So if you run your local ELK stack, you need to deploy Elasticsearch, you need to deploy Kibana, you need to run Logstash. Depending on the log volume, you might have dedicated machines for it, or you use a software as a service like Logsene. To explain the difference of traditional server setups and log management and Docker, I would like to start with a traditional setup with an example of a web server, which writes two types of logs, an access log and an error log. And in the log shipper, we know exactly the source, so we can define a parser for access logs, and we can define a parser for the error logs to get the structured data. On Docker, it's a bit different because Docker logs are basically the console output of containers. So we get the standard output and the standard error stream. And the most official images log to the console, and we get a single stream of logs from the Docker daemon to the log management. I will show you an example for an Apache web server. So this command starts an Apache web server, and then we look into the Docker logs using the Docker logs command, and we see then some startup messages that something is not correctly configured. It has no timestamp. The next message has a timestamp at the beginning, and the third type of message is the regular access log with the very structured with the IP addresses, timestamps, the URLs, the status code, and the size of the page. But actually, you see Docker logs of this container give you three different types of messages, and when you do log parsing, you have to create the parser for all of them. So what are the options for Docker logging? I will talk today about Docker log drivers. There are different log drivers you can use, like JSON file is the default. You can ship data to syslog, to Fluentd, journald, or Gelf. Then there is a Docker API. And there are systems like Logspout that take the logs from the Docker API and ship it to a remote site. The Sematext Docker container fits to the same category. I will not talk about the last possibility. So for example, you can build your custom image and install or configure your application to send your logs to syslog. And yeah, there are many ways to deal then in a very homemade way with the logs. So I will talk today about the most general solutions, the log drivers and API-based logging in containers. Others refer to it like logging as a microservice. So let's talk first about Docker log drivers. It's a very simple way to forward log to remote destinations. And the setup can be done for each container. So you can start a container and specify these messages go to a syslog server. And you can start a second container and you can say, okay, these messages go only to the file storage. What you should know about log drivers is if you use a different log driver than JSON files, and I will go back to the other slide before, if you use JSON files, your logs are stored on the Docker host, and you can use the command line tool Docker logs to see these logs on your console. If you use a log driver, then it means the Docker logs are shipped via the log driver, like this log, to a remote destination, and you don't have your logs on your local Docker host. So the command Docker logs will fail when you use one of the log drivers that ship the logs to a remote site. So yeah, and this is already a disadvantage. It's very nice. It is a simple forwarding, but you don't have your logs locally on your host. And there is no log parser inside, so it's a very simple mechanism. And For TCP-based receivers, for example, you can ship logs to syslog via UDP or TCP. But if you use TCP, it's connection-based, and if the syslog server is not running, you cannot start your containers. Or if the TCP connection breaks, it's the same for Fluentd. Your container will also stop working. I haven't seen an option to use TLS encryption. If somebody knows how that works, I couldn't figure out to establish the TLS connections with the default logging drivers. So I will go now for a little demo. Give me a second to switch to my terminal window. And take a few commands I like to show. So first of all, we need a little syslog server running. I show you here our own development. It's a little Sematext tool. It's called LogAgent.js. It's made in Node.js, and it is started with the parameter -u 1514, means it starts a syslog server on the port 1514. It puts the messages to the console and stores it also in Logsene. So let's run first this tool. So basically we have now a local syslog server running. Then I will start an Apache container. Let's get me the command. And what I like to demonstrate here is, because we are listening in here on the UDP port 1514, and we start Apache web server with a log driver for syslog, but we use here TCP localhost, and there's no service listening, and that's why the container fails. Sorry, this is another reason it fails. I will remove this container. This is my web app container. Just 1 second. Okay, now it's gone, and I can start it again. So I run again the command with the syslog driver, and now we see the reason why it fails. It fails for the reason that the connection to the port 1514 is not possible. So I cannot start my application because I choose the TCP-based log driver. So let's remove again this container configuration. So it's gone. And start a second trial. Now we use UDP. So I changed only this one from TCP to UDP, and we have a UDP service running. So the world should be fine. 1514 is the port, the same port here. And let's start the HTTP daemon. You see in Docker PS that the service is running. And we see here on the console some output. These are the log messages in YAML format, already passed by my tool, the log agent. Another interesting thing is, if we try now to use the docker logs command to see it, to see the logs from my web app, it fails because Docker log driver is used. So I have no access on my local machine to the logs of this application. All goes to this syslog server. And I think that's something you should know when you start working with the logging drivers, that such issues can appear. You can now also put some load on this machine. Say 20 parallel requests to this web server. So we sent then 206 requests to the web server, and we see then here the get messages already structured by type. This is access common, is a web server log format, having all the parameters already passed with our log agent tool. On a regular syslog, you would only see this line, which is not parsed at all. Okay, that's it so far. I did also forwarding to Logsene. So there is a possibility. We have a little tool to search the logs. I have to first log in with my email. So you can configure that, or the tool asks for it. And enter my password. And it shows me the applications, and my application number 13. And it shows then the search results. So I show the last 5 messages from this HTTPD container. So this is actually the query, and these are the fields I like to show. So in that case, I shipped my logs to a remote destination, and I was able to watch it also on the console with this search tool. So let's move back to the presentation. I think a little recap of what we have seen is if we start a service with TCP option and the TCP server is not available, the command will fail. UDP is stateless. It's good to ship logs to a local machine, local syslog server in the local network, but it's then more independent, so your app can start and run without dependency to the logging service. And in any case, when you use a log driver, which is not the JSON files log driver, which is the default, you are not able to use the Docker logs command. Okay, let's see what else we could do. If we use a API-based solution, we get the logs from the Docker daemon. Because we can keep the default driver JSON files, it's possible to retrieve the logs via the command line tool, and we have it somewhere on the file on the Docker host. There's a very popular solution for such API-based logging containers, which is called Logspout. And it has nice features like it can handle ANSI escape sequences. So a container output is the console output of the program running in a container. And today it's very popular to use colored logs like error messages in red and success messages in green. But basically it needs ANSI escape sequences in the terminal to color these text lines. And if we like to parse logs to get structured data, it's then very difficult to define, for example, regular expressions that deal with the ANSI escape sequences. So the nice thing on Logspout is it has handling for these escape sequences. It can remove it. In addition, it has support for TLS. So in that case, we can choose a syslog server which is on a remote site, and it can use encryption. And because it uses the API, the container can start without any problem, because there is no dependency between our application container and the logging. So the logging runs really in parallel. Your container starts, makes some output, and the Logspout container is listening to the events from the API and can forward the events to a syslog server via UDP, TCP, or TLS. It has also a little API, so you can configure and filter which containers you like to monitor, or you can use the HTTP API to see real-time logs via curl command, or open a browser window and access it. But there is no security around it, so be careful when you use the HTTP interface that you don't expose it to the public world. It is yeah, there's no password protection or encryption on it. Yeah, I think that's so far for it. There are a few disadvantages, like it's a nice concept, but they stopped really on log shipping. There is no functionality in this container to add a parser to parse the logs before you ship it to a remote destination. For syslog, again, rsyslog is a good tool which has log parsing capabilities, and rsyslog can also output the parsed log files, for example, to Elasticsearch or to our service Logsene. In addition, the container doesn't use all capabilities that it could use from the Docker API. It's only watching log messages. It's not looking into Docker events or Docker metrics. So let's finalize Logspout. I could also give you a little demo about it. Just a second. Let me switch again to the terminal. So what I do now is I will remove, first of all, again, my web application from before, which was configured for the log drivers. And then I will run the Logspout. Just a second here. Got somewhere my command for it. Okay, got it. So let's see how we start the Logspout. Again, Docker 1, we call it Logspout, run it in daemon mode. It needs access to the Docker API, so we pass here the volume for the Docker Unix socket. If we like to use the HTTP interface, we have to expose the port 8000, where it is listening to. And we say here we use forwarding to syslog via UDP. And because it's running in a container, we specify now another network interface, which is the Docker 0 network interface in the container, which ends up on the Docker host. So let's run Logspout. PS. And we see Logspout is running. Now I can start my web application again. And on our UDP server, we should also see the messages going. So if we do curl localhost on port 80, we get the Apache message, and we can retrieve the logs from Logspout using another curl command like curl localhost. It's listening to 8000, and I think /logs gives us then the current logs. That's one curl in another console. I don't know what is wrong right now. I think I exposed to port 8000. It's connected to it. So maybe I got the wrong URL. So let's go back to the slides. It's 8000 logs. In any case, you would see then the log messages in your curl console running. Another container which is using the Docker API for logs is SPM for Docker. Please don't be confused about the name. Initially, we started to develop our container for performance monitoring, and then we added the collection of events and logs. It is very similar to Logspout in the mechanism it works, like taking the logs from the Docker API. So in parallel, we can use the Docker logs command. So all functionality in this regards remain the same. We have also filters to filter for specific images, like when you start our container, you can specify, I want to see all logs from images that have HTTPD in the name, or Nginx or MySQL, and you can exclude other services, like if you use an Ubuntu toolbox, you can then exclude, for example, the Ubuntu image. The difference here to Logspout is really that we have a parser inside with a pattern library that matches many logs from standard application. And that's a nice thing on Docker, because you have the official images, for example, an official images of Elasticsearch or of Nginx. So when you start the image, you see which log format is used, and we can provide default patterns for it. So we have all these patterns on GitHub, so you can look into the LogAgent.js project, which is a sub-project of our container, just the logging part, and there you can also find the patterns. It collects logs, metrics, and events, and it ships it immediately to Logsene using HTTPS encryption. And again, Logsene is something like a hosted ELK stack. In the background, we run Elasticsearch for you, we run Kibana for you, and you don't need to worry about maintaining your own Elasticsearch cluster. It has the same, let's say, conditions like Logspout. So if the logging container is not running, we are not collecting logs. So we really recommend to start every logging container the system startup using, for example, a restart policy to start it automatically. I will give you an example how to start this. So we have then the docker run command again. It's similar to Logspout. We use the Docker API, so we pass the Docker socket to this container. If you like to use custom patterns for parsing of your logs, you can specify a pattern definition file. If you don't specify it, it uses the default patterns delivered in the LogAgent.js sub-project. And we pass the host name. The reason for it is this log collection runs in a container, and normally we would then see the host name of the container. And so we give a parameter host name, so it can send us the name of the Docker host. And as destination for the logs, we specify then a unique key for each Logsene application. So if you register to Logsene, you can create an application, and then you get this long number, which is a unique access token for your Logsene application. In case you like to get performance metrics, you can use the SPM token in a similar way, and then you just specify the name of the image, which is currently Sematext SPM agent Docker, and we might rename it in the coming weeks. So then you run your HTTP service, and I can put load on the web server. So if you like to see it, I can again switch to the console and hope the demo gods are with me again. First I stop one if it runs before, then I take my command to start it with all the parameters. It's a long one, it started successfully. You see also that I specified to remove the NZ escape sequences and the parameters described as before. And I hope the application container with the web app is still running. Yes, it made some traffic to it. And again, I could search in Logsene for the latest messages. Let me switch to the web browser window to see if all our logs did arrive. And here we are. It's taking the logs from the CH. 881 it got. And what you see here is very important. You get structured logs. So we have the image name, we have the messages, the method, status code. And if you look to the original log line, we have nothing configured to parse these logs because it's one of the default patterns for web servers. It recognizes automatically that these logs from this container have this format, and then it can parse it. Even if the container is not named HTTPD, it has a mechanism to find out the format automatically. So if we have more container running, we can also easy filter for specific container. We could also save this query, and that's also the place, sorry, twice to filter, where we can create alert either by the number of logs, or we say there is a machine learning algorithm which says if the number of logs goes higher in 30 minutes from the regular level, then we can also get alert notifications. Just a few more things. We have Kibana inside, so we can start here Kibana. But I switched to another window because Kibana needs a bit for loading. So let's have this. Well, this example has no current data, but you can build your own dashboards then for your Logsene applications in Kibana to see, for example, how many HTTP requests have been there, what are the percentiles of the response times, and so on. Depends on your application, and you can use all features that we have in Kibana. Another thing I would like to show you when I have opened a web browser here is the correlation with metrics and logs. These are CPU metrics from the Docker containers. And we have then an easy button to access the logs in this container. And you see also here that the HTTPD service had the CPU spike by serving the request, and the number of logs was higher at the same time. If you need to look into it, you can easily switch and get then the log message at this time. One more thing, there is events too. So you see, for example, here, all events that happens in the Docker daemon, like creating new containers, destroying containers, and you can correlate then metrics, logs, and the events in a single place. Let me switch back the window to my presentation, because I think I'm a bit late in time. One thing I didn't talk about is that when you run Docker, it's supported on many platforms, for example on CoreOS, and I have an example here for the support on CoreOS. So you can run our container on CoreOS, then it works like on any other Linux. So it takes the logs from the API and ships it to Logsene, but there's something special. On CoreOS, they use journald as standard driver for Docker, and we have integrated a forwarding service. So what we can do, is that the Docker daemon gets the logs to journald, and from journald we can forward it to a logging gateway running in our container and then forward the logs to Logsene. The interesting thing here with journald is you can query the logs since a specific timestamp. For example, when we shut down the machine or shut down the container, we can store the last date of logs we have seen, and we store this configuration in etcd. And when the container or the CoreOS host comes up again, we read this timestamp, and then we can ship out logs. This means you can also see boot messages from a CoreOS host when you use this log forwarding service. If you look to our blog, you can find and search there for CoreOS. You can find different blog posts about this issue, and it points you also to the installation instructions for CoreOS. Okay, let's summarize it. It runs in a container. It takes everything from the Unix socket, and because it is a containerized logging service, it can run on every platform that supports Docker. We have customers that run it on Amazon ECS. We use it. We have special support here for CoreOS, Dice, RangerOS, and we have also seen it running with Kubernetes, Mesos, and Swarm. Again, back to the name, it's currently called SPM for Docker, and this is the history thing, because SPM is the monitoring tool, and it was developed as monitoring agent, and we added then the logging functionality. It's now a combined agent for logs, events, and metrics, and the Logsene and the SPM user interface share common functionality like security, role-based access control. We have scheduled webhooks and the alerting and ChatOps functions, and an API to control the functionality. We are close to the end, and I would like to come back to a slide from the beginning where we have seen the different types of log messages, and it's now about a place to add log parsers into our architecture. So regardless if you use log drivers or log containers, you need somewhere a log parser to structure your data. If you use log drivers, you can add it to our syslog, you can run a Logstash or Fluentd server, and from there you can insert the logs into Elasticsearch or Logsene. And what we have special in our solution is that the log parser is inside of the monitoring container, and this reduces your stack. It makes it many things much easier. There's only a single place where you have to configure log parsing. It comes with default patterns, so for many applications you don't need to configure anything. And instead of running then a local ELK stack, maintaining your own Elasticsearch cluster, you can forward it to Logsene. I think that's it. These are the things I'd like to show to you, and we can summarize then that we talked about motivation for centralized logging. We spoke about log drivers, advantages and disadvantages, and the very nice option to use logging containers that use the API, and where we can place log shippers to use to make then analytics and alerts on it. We have not seen much about Docker monitoring, so feel free to join our Docker monitoring webinar. And yeah, I don't know if we have time, and we have planned to answer questions. So Mick might be able to help me with that.
Yes, we do have a few questions, Stefan. So why don't I just read them off to you and you can answer them. And if we don't get to everybody's, again, we'll email you afterwards. And if you have some while we're talking, just submit them to the in that questions piece of the doc you have there for GoToWebinar. All right, so let's see. Actually, let me just reiterate. If you have any questions about the stuff you've seen today, like if you try Logsene and want to, give that a go, and you have questions, that's fine. You can let us know. And as Stefan has put up there, we have a discount coupon if you really want to give it a try. So that is that. So let me get the questions. All right, so first question, if the server where logs are supposed to get shipped is down, will I lose them? And what's the best way to ensure logs are not lost?
Well, with the design of the TCP connection, you would not lose logs because your container doesn't start up when it has no TCP connection to the logging service. On the other hand, it means that your applications depend on this logging service when you use the Docker log drivers. When you use the API, then you can store your logs on the local host, so you're also able to ship it later on with a manual procedure back to the central storage. So you have your logs on the host, and you have it in a remote site when the API-based container was running and it did collect the logs.
All right, cool. Next question, do all options, log drivers and Docker logs API, guarantee all logs can be collected before the container is shut down?
So could you please repeat again?
Yeah, the question is, do all options, log drivers and Docker logs API, guarantee all logs can be collected before the container is shut down? It's a little.
I think the best chance is with the API-based solution, as if, or you use the TCP options, but the TCP option again has the problem that the container might go down. On the other side, it ensures that you get these logs. And the API-based solution, as long the logging container is running in parallel, it gets all logs from all containers. That's it. So you have to choose these two options.
Okay. Let's see, next question. If I don't want to collect logs or metrics from some containers, can I configure Sematext Docker container to ignore some containers?
Yes. There are filter options in both, in Logspout and in our solution, where you can configure which image names or container names should be used to collect the logs. So you can exclude or include the containers as you need it. Maybe you don't like to add short-running containers where you run some toolbox inside. Typically, people like to collect the logs from long-running services like web servers, databases, and so on.
Okay. Let's see, a couple more. Which log driver option do you recommend and why?
Well, I think the best option, one very interesting option is to use journald, because journald collects has then an additional configuration where you can say store the logs on my local disk. So you have it on the host in case there is some network connection not available, you still have your logs on your local host. And it is possible to query journald for logs and ship it to a remote site. This is actually what we do with CoreOS. So there is the journald log driver enabled, and we take then the logs from journald and ship it to Logsene.
All right. So last question here. Does your container run on Amazon ECS?
Yes, I think I mentioned it, that our customers using it on Amazon ECS. So you create your task definition to run the container on ECS. It's not a command line like Docker Run. It's a JSON file where you specify the image name and the parameters for the container, and it runs there without problem.
All right, that is all the questions. So that's going to do it for today's webinar. Thank you to everyone who attended. We'll follow up shortly with links to the presentation and a recording and some Docker content that you might find interesting.